Good day. Today I'm going to talk to you about our WedgeOS. I'm going to go under the hood, look more into its functionality, and give you a complete overview of what we can provide to you in terms of network security services. Now, to start this whole story, I'd like to talk to you more about why did we implement WedgeOS. Now, if you look at what's happening with networking, we're having a paradigm shift in networking. The easy world of, or the simple world of having your PC connected to a network, then connected to a firewall, and then eventually connected to an internet is still there, but it's actually getting more complicated. We're seeing a lot more than just basically that. We're seeing cloud computing. We're seeing things such as application stored security as services, Dropbox, for example, Google search. We're seeing also a lot of users, nearly 2 billion users. And in addition to that, we're seeing Internet of Things, which basically your photocopier, your fridge, or your car, all connected to the internet. Now, the old paradigm of protecting the network is no longer useful. It's no longer actually capable of protecting against threats. And why is that? Because if you look at what's happening in this paradigm shift, previously we could protect the network by putting an anti-malware on your PC, and you could have a firewall. And both of these two components, the firewall and the anti-malware, would work very well in tandem. That's not the case anymore now. Your mobile device probably would not be running any kind of anti-malware solution. It's simply too complicated to put it. It would drain your battery very quickly. In addition to that, it just doesn't have the capacity to do so. And guess what? You're doing most of your applications on your mobile device. You're checking your corporate email. You're basically retrieving files. You're doing a lot of processing and so on. So the problem is, how can we protect against this new world? And given that fact, that existing solutions cannot protect against these kind of, threats in this today's connected world, cloud-connected world, we need a high-accuracy solution that sits in line, scans network traffic, and ensures that malware is blocked before it comes to your end device. So let's take you through WedgeOS and what we have done in the industry to ensure that we can protect against these new generations of malware and to support this new paradigm of a cloud-connected world. Well, first of all, we have developed a platform. It's a network security services platform. It sits in line, scans traffic at very high speeds, and ensures that we can stop malware before it comes to your endpoints. How do we do that? We have invented something called deep content inspection. It's a high-performance deep content inspection engine that would scan MIME objects and would ensure that we can stop malware before it comes to your endpoint. In addition, we have also added in deep packet inspection engines for flow threats as well. Now, inspection on its own is not sufficient. You have to add the services as well so that you can stop malware. So we actually have prepackaged a rich set of advanced security functions such as anti-malware, anti-spam, web filtering, data loss prevention, and so on. And we'll be speaking a lot more about these as we go through the presentation. Now, the last thing we have here is if this is going to be deployed to support things such as cloud installations or things such as virtual installations or virtualized infrastructure, it cannot rely on custom hardware. And we have built this engine such that it utilizes pure software. It's built on pure software and utilizes basically whatever hardware you can have there. That was very critical from day one for us as a company to ensure that we cannot and we do not lock up our customers by relying on certain custom ASICs or FPGAs or you name it. Now, the last thing in addition to that is we wanted this solution to be affordable. So we actually had to work very hard to optimize our deployments, the footprints of our deployments, such that they have the smallest footprint. They are quite easy to integrate in the network. They can be integrated as a transparent proxy, or whatever have you. But in addition to that, it would run on common off-the-shelf hardware. That was very critical for us. And then finally, we can actually update these installations all over the world so that you as a customer would benefit from the latest research that's out there, latest intelligence into malware that's out there. And we have a cloud-based real-time security intelligence platform there as well. Now, the last thing that's quite important is we also recognize that we, as a company, we're actually building an ecosystem with this platform. So this platform has to allow for new research out there. So, for example, companies that are coming up with new anti-malware research can easily plug in to our product, and that's supported through the Open Service Bus. On our website, there would be another talk that will speak about that and further elaborate how you can plug in your intelligence, your security intelligence and security malware threat intelligence into our engine. Now, before I go in, I'm going to speak to you about a high-level description of our WedgeOS and speak to you about the engines inside it, and then take you through it a step at a time so that you can see what we have done and you have a good idea of how it's built. Now, we start off with the concept of traffic. The WedgeOS in its deployment form, whether it's an appliance, a virtual appliance, or a cloud, would have to intercept traffic somehow. Now, once it intercepts traffic, we basically have scanning functions, and we have deep packet inspection as one of the scanning functions. We have our own proprietary deep content inspection, which is patented, and we own the patents to that. And then once inspection is complete, the result of inspection is MIME objects. Basically, you have to take these MIME objects and now start scanning them, or basically start matching them or doing inspection on them further to see whether they have malware or whatever have you. From that point, we basically have the Open Service Bus that makes this MIME objects that the scanners have produced and subjects those to the different intelligence that we could be having. So in our engine pre-built, you'd have an anti-malware intelligence, you'd have antivirus, anti-spam. In addition to that, you'd have our own built data loss prevention to ensure that documents that are proprietary or confidential in your company would not leave the organization or would not leave your own mobile device. So that is basically it in a nutshell. That's what WedgeOS is. We have these, inspection module as well as the Open Service Bus that makes the inspected content available, and then we have the intelligence, which is basically the signatures and whatever have you. Now, the advantage of that is that now we can, with WedgeOS, we can enable any network security function to run on a network. It can easily integrate new services. It can apply any kind of network applications as well. And it can run it on any host. And that is quite important because we don't have any kind of reliance on custom hardware, ASICs or FPGAs or whatever have you. And in addition to that, it's elastic because at the end of the day, the way we've designed it is that it can actually manifest itself into different images depending on the kind of traffic load you have in the network. Now, inspection is quite important to recognize that we do support two types of inspection in our engine. The first is content inspection, where content is actually assembled the same way as your endpoint would assemble it. And we take this content and then subject it to different intelligence, whether it's anti-malware, anti-spam, and so on. This kind of inspection, where we reassemble the MIME objects and subject it to deep content inspection, is our own patented technology. That's what we have developed, and we're able to do so inline without introducing any noticeable latency to the traffic. But then, deep content inspection on its own is not sufficient because a lot of threats are also part of the actual flow. So basically, you can have threats in the handshake or other things like that. And that's where we have also the deep packet inspection. Deep packet inspection, as you're all aware of in the industry, if you're an industry practitioner, you know it has been available for quite a while. And we basically implemented it in our product, in our WedgeOS for product completion. Deep packet inspection would allow us to detect again and prevent and block threats such as the packet header, packet body, and so on, and would provide you with other functionalities such as we can have server protection, we can have application control, and so on. At the end of the day, we are building an ecosystem here. We recognize that we as a company, while we have built and patented our inspection engines, we do rely on the industry to support us through the different threat intelligence. And that's why we have the Open Service Bus at the bottom there that allows for the integration of new services and new intelligence as needed. So with that in mind, we're going to take you through how both of these engines work together. So on the left-hand side here, I do have the traffic going through the source to the destination. Our WedgeOS would be deployed in line with the traffic, or traffic is routed it somehow. And then we have the packet filter. Basically, we have this module in our product that takes the packets and makes it available to the different engines. So the engine rules could be deep packet inspection engine rules, or could be a deep content inspection engine rules, and that's where you would invoke the different engines as needed. So the deep packet engine is typically invoked first, because usually you would like to inspect for threats that are on the envelope, in the headers, and so on. And if they are okay, if there are no threats there, then we can go in and subject them to further inspection on the actual deep content. So that's where we subject the content itself. So think of it as two-phase scanning. First phase, where we're scanning for malware that could be in the actual envelope, in the handshake, in the packet headers, and so on. And then the second level is now, if the first is okay, we go on and start checking the actual payload, the actual content. We assemble the content and subject it to deep content inspection. So from that side, what's quite unique about WedgeOS is these two phases of inspection, the packet, or we call it the flow, as well as the content, but also the fact that we have the concept of service chaining. Now, service chaining is a concept that's very, often talked about in telcos right now. You find a lot of telcos and operators and so on talking about how can we change this service and so on. We have it already. It's implemented within our engines. We can scan for both, packet or flow threats, as well as we can scan for content threats, and we do so without any noticeable latency in the network. Now, the other thing now is that I'm now going to take you through the technology a bit further. So remember, we talked about WedgeOS having this packet inspection or flow inspection, as well as content inspection. I'm now going to take you through them one by one. I'm going to start first with the most complicated one, which is the deep content inspection. Now, we start off by having what would users do on the network. So a typical end user would probably be using a web browser, trying to go to their favorite news or favorite web-based application, or they can be doing email. So you could be sending email or whatever have you, or you could be having your typical apps, applications on your end device. These applications could run on Android, could be running on Apple OS, iOS. The applications could be actually quite agnostic to both technologies, to both platforms, running on pure HTML5. Regardless, these are the activities we see people doing on the network. So an end user would be typically doing all of these kind of activities. So how do we go ahead and scan them? Well, this is what we do. Traffic is flowing through the network, and then it gets intercepted by our deep content instruction, which is part of our deep content inspection engine. And there we have the very first component of our DCI engine, which is called the subsonic engine. The whole goal of a subsonic engine is to scan for content, ensure that we're not continuously scanning the same content again and again. For example, if I found an interesting, say file, a music file, whatever have you on the internet, and I'd like to share it with you, so I probably was browsing, and I'd like to share it with you by email, and I have retrieved the content first, and then on its first time through, it got scanned. The next time when I'm emailing it to you, it should not be scanned again. That's something we have in our subsonic engine. We basically fingerprint content to ensure that if we have seen the content, we don't scan it before. That gives us a huge performance gain, actually, on typical for any protocol. It's around 34 to around 45% performance gain. The second thing we do is what we call as green streaming. Now remember one thing, we're retrieving these objects. So imagine the following: you're retrieving a YouTube file, you're retrieving a PowerPoint file, a Word file, whatever have you. Now, if you're going to scan this file and scan it all in its entirety before you send it back to the end user, at such time sessions would have timed out. So we had to introduce what we call as the green streaming technology, which allows us to scan the content while we're delivering it. So we're not waiting for the content to be delivered first, then scanned, and then released. We're actually scanning it as it goes through the network, and without basically compromising the security of the end device. And then we have others. We have other engines there. We're not going to speak about them right now, but basically you can see where this is. It's sort of like staggering of engines that we can scan the contents through. And then once the content's available, again, the open protocol bus comes into play, and that's where the content is made available to the different threat databases there. So we can scan for things such as anti-malware, we can scan for things such as anti-spam, and we can also scan for zero-hour threat using heuristics as well as APTs, and we can also have embedded sandboxing. All of these are built into our engine. Now, what does that mean? It means that we can now do a lot of things. First of all, we can scan content that's coming from different protocols. So if the piece of malware that's being delivered to you is what's called multi-vectored, so it can start on email and then move to things such as HTTP or vice versa, because we're seeing all protocols and we're scanning in depth all of these payloads, we can stop the malware wherever it's starting, wherever it goes from there. Because a lot of attacks nowadays, these multi-vectored attacks, can start from email, then move to a web protocol and vice versa. And it's very important to be able to do so. To the best of my knowledge right now, other technologies out there would not be able to do that. The second thing is that now that I have the content, I can do whatever I need with it. I mean, I can basically subject it for your typical anti-malware, where I'm going to compare it and match it against your typical signatures. So in our engine, actually, we can have multiple signatures from different vendors. So a given installation can be, a given piece of content can be scanned against over 60 million signatures. That's one thing. We can scan it for different things such as spam or whatever have you. But more importantly, we can now put this content and have further analysis. We can now scan it for your typical sandboxing, where you put the content into a sandbox and try to see its performance. Of course, you have to time box it to avoid any latency. That's also possible in our technology. But also heuristics. And heuristics would allow you to see the content based on its registered type, based on its type, based on the MIME type it's registering, or it's basically claiming to be. We can now scan the content and ensure there is nothing that is out of normal in it. For example, if you have a Word file or a PDF file, this file should not contain commands to disable parts of your registry or whatever have you. If we find that into the file, then the heuristics module would immediately say, well, you know what? Even though this file looks benign, it probably is malware, because it does have some kind of anomaly. That's the benefit of that heuristics engine. So the benefit of the deep content inspection, again, is that we scan the traffic, we assemble the payload exactly the same way that the endpoint would see it, and then we'll scan it for malware, for heuristics, for sandboxing, and so on. And we do all of that without introducing any kind of noticeable latency. Because of this kind of innovation, we have been awarded patents for our technology, and it is patented all across the world. And not only that, but also people in our industry have recognized the value proposition of our technology. Basically, from Forrester Research, they made it very clear it's unique because it delivers high performance, and now we can basically have in-depth scanning of content. And that actually enables this whole new paradigm of computing, where you have cloud, where you have mobile devices, and you cannot install any kind of anti-malware or anti-spam, whatever have you, solutions on these devices. So our product would sit in line, scan the content, and ensure that you're having the best of breed security without in any way changing how the network is configured or imposing any kind of architecture. So the most important part of our technology, the subsonic, actually allows us to scan content at very high speeds. And actually, if I'm going to tell you that it can do so without introducing noticeable latency, without showing the proof, then there will be some doubt there. So let me take you through what we have done. These are, by the way, lab tests, and for the very first time, we're making these available in public to the whole world to see. The first one is, can the deep content inspection engine scan very high concurrent sessions? And that's very important, because think of it. If you're deployed in a network junction, and typically are deployed in operators or cloud installations and so on, the number of sessions are huge. We're speaking about millions and millions of sessions. And so the first one is, from the lab test, we can show here that we can have sustained performance over 350,000 sessions for a typical 4-core processor. The second thing that's quite important is how does our engine perform compared to conventional engines when it comes to scanning, especially when the payload is huge. Because guess what? If we're sitting in line scanning the content that's going to be delivered to your end device, you could be watching things as large as a 2 gig movie. You could be downloading the latest upgrade for your phone. So these payloads are high and are heavy and they're large. So it's quite important that our technology scans linearly so that we don't basically introduce huge latency there. So if you look at the performance we have, we're actually, we actually extend and do a very good job linearly with our throughput there. Now, remember one thing. A lot of people would come up and say that you have to have custom hardware. You have to have the latest ASIC or KVM or whatever it is, and here we are, we have invested, $500 million or $20 million, whatever have you, in developing our own custom hardware to be able to scan content. And that's good, don't get me wrong, it's good for them, but we believe that conventional hardware is needed, support for conventional hardware is needed, simply because of the cloud. You cannot guarantee where WedgeOS would be delivered. It could be delivered from a cloud on Amazon. It could be installed, on rack space. It could be installed anywhere. It could even be installed on one of your much simpler PCs. Regardless, we have to be able to scale and scale nicely without any kind of reliance on hardware. And that last figure there, figure 3, shows how the performance of WedgeOS scales very nicely with a number of cores and a number of processors. As a result of that, you don't really have to rely on custom hardware. So we've managed to basically do the following with our deep content inspection. We have the most in-depth scanning, the most accurate scanning. In addition to that, we're not introducing any kind of latencies, any kind of noticeable latencies in the network. But more importantly, we can do so with common off-the-shelf hardware. All of these are benefits to the end user and to people who are deploying our technology. Now we're going to show you how we avoid having to introduce latencies in our solution. And this is accomplished with what we call as the green stream technology. I'm going to show you diagrammatically here how we do so. So assume the following, or actually not assume the following. This is what typically happens. You have an end device that could be your mobile device, could be your iPad, your iPhone, your Android device, whatever have you, and you are accessing content somewhere in the world. Basically, you could be accessing your favorite CNN, your favorite web-based application delivered from a security as a service infrastructure, whatever have you. And you have subscribed to this security service provided to you by one of the operators, whatever operator you have subscribed to, and our solution is stored in line. So how do we scan content without introducing noticeable latency? This is how we do it. As content is flowing through, so basically your device would click on, say, CNN.com or Salesforce.com, whatever have you, and then the content is starting to flow through. As content is flowing through our deep content inspection engine, we will scan it. We'll scan the very first part and then release it quickly. And then, when more parts come in, so for example, part 2 comes in, we basically scan parts 1 and 2 and then release part 2. And then when part 3 comes in, right, and in this case we have it showing on BCure, which is actually another version, the appliance version of our WedgeOS, then basically we'll scan it and then pass it through and so on. And then finally, when the whole payload is available, at that time we'll scan it one more time, scan the whole content one more time before we release that last part of the payload. The advantages are as follows. First of all, your end device is getting the content all the way through, and you're getting pieces of the content, which is the normal way of getting content anyway, but you're getting that when it's being scanned, ensuring that we're not getting you any part of malware. And at any given time, if parts of the parts of the content that were delivered contain malware, then at that time we'll terminate the whole session, result of which is that you're not getting any kind of malware. Now, the advantage of this green streaming is that we're scanning content and we're doing so as we're delivering the content to the end device, which reduces network latency. In fact, it's very few, microseconds all the way through. In addition to that, what green streaming would do is that it would automatically adjust itself based on the throughput, based on the speeds that you have in their end device. Many common cases we have seen where your mobile device is on a very slow part of the network. It could be, for example, on GPRS or on 3G or whatever have you, and the speed at that time is slow. But the server on the other side could be very fast, so we have to adjust for the throughput and ensure that we're scanning content as needed based on the throughput. In addition to that, we actually have the content scanning, the full context scanning at the end of the whole payload, so we can do so without in any way compromising accuracy and ensuring that you have the whole payload scanned as well one final time before it gets delivered to your end device. The green streaming technology allows us to basically lift our claim, which is we can scan in depth without introducing any kind of noticeable latency to the traffic. Now, all of that is good. So we've spoken about WedgeOS. We've spoken about the different engine side of it, the deep content inspection engine. We spoke briefly about the deep packet inspection engine, which I'm going to speak about more down here. We've spoken about the subsonic engine, part of the deep content inspection engine, which allows us to scan content and minimize scans. We've spoken about the green streaming, which allows us to lift our claim that we're not introducing any kind of noticeable latency. The last thing is, how does this whole thing integrate into the network? And that's quite critical, because if you're going to support operator-type deployments where there are millions of subscribers going through a single cloud instance or a single appliance bank instance, it's quite important that you can integrate easily and nicely without having to do any kind of huge network reintegration. We do so through three tenets. The first one is we're stealth, meaning that when we're installed, we basically have zero imprint. We don't basically leave MAC addresses and so on. A lot of solutions out there, like proxy solutions and so on, would leave their MAC address, making it difficult for for operators to deploy these solutions. In our case, we don't leave that at all. And the second thing is that we actually have to support things such as load balancing either for fault tolerance purposes or just for normal scaling up. Typically, networks can start off with a limited number of users during the day. As you add on more users, as the service becomes popular, whatever have you, we have to scale, and we actually support different types of load balancers. But in addition to that, it has to be future-proof, such that our solution can be deployed both in virtual, physical, or software-defined networks. And that's what we have here. In fact, in our technology, in WedgeOS, we support different types of transparencies, whether it's IP transparency or VP or MACLAN transparency. And that allows us to be easily deployed in stealth if you have both transparencies on, allowing the solution to be installed easily with either different types of load balancers, or in addition to that with the network without having to reconfigure or re-architect your network. Now, the thing that we want to speak about next here, so we spoke about the deep content inspection, we spoke about how it scans in depth, we spoke about how it can integrate so nicely in the network and so on. Now, the most important thing is that we have to recognize that there are lots of researchers out there. There's a whole industry that's producing different malware signatures and so on, and how do we play with them? And we actually play very nicely, because we have this last construct I'm going to speak about here in deep content inspection called the Open Service Bus. So out of the box, pun intended, you can have these different scanners. So we do have different actually malware support. We have anti-spam support, and we have content matching, web filtering, and so on. And in fact, out of the box as well, we have partners with industry leaders such as Kaspersky, McAfee, CloudMark, and Bitdefender, who provide us with their different signatures in the solution. However, if you are a malware researcher, or if you are a signature or intelligence provider out there, and you would like to partner with us to make your intelligence available to our engines, please call us, and it's very easy to integrate your solution into our Open Service Bus. Now, our whole goal with the Open Service Bus and with WedgeOS is to make sure that WedgeOS is an infrastructure for third-party security solutions. Our innovation in this space is being able to subject content and network traffic to be scanned at very high speeds. That's our innovation. When it comes to the intelligences, we look forward to working with the industry partners. We've already done that, and we look forward basically to make sure that going forward, our subscribers or operators and whatever have you, look at WedgeOS as more like an app store. You can plug in the different security services that you want to have. I'm going to try and introduce to you the deep packet inspection part of our WedgeOS and introduce it through its applications first before I delve into its different features and so on. And the easiest one to recognize if you're a security practitioner, if you're an IT manager or CISO or whatever have you, is to recognize the application of next generation firewall. Probably 3 years ago, industry leaders came out and developed next generation firewalls, which actually would provide you with what we call as blocking on application types. So you can go in and look at the different applications in your network, and you can control what's being accessed and so on. And WedgeOS has exactly that. We also have the deep packet inspection engine that enables a lot of the next generation firewalling. So inside of WedgeOS pre-built, we have application control, which allows you to select and block different types of applications. We also provide server security because we recognize if you're deploying this, not only is it applicable for you as an end user of subscribers, but you can put WedgeOS also on a segment of the network where you have servers, so you can protect these servers. But in addition to that, we have also provided a web filtering component in our deep packet inspection that can provide and enforce acceptable use policies and acceptable web usage on the network. And what we have done here is we have actually contributed something that's quite unique. We have done it in such a way that it can work in any part of the handshake, meaning that it can be developed or deployed asymmetrically. And that's actually quite a particular important use case for a lot of operators where you would like to ensure that you can provide packet inspection and web filtering for just part of the traffic, not all of the traffic. Now, the application control, as you can see, here is a part of the interface where we can now go in and allow the administrator to block or to control things such as torrents and P2P or whatever have you, or at least monitor them. Now, that is the application. I'm going to go now in depth into our deep packet inspection engine, its architecture, and how we've implemented it. Deep packet inspection as a technology has existed for quite a while. In fact, it's probably one of the oldest technologies in network inspection. I think it started off in 1996, if my memory serves me right. And there are lots of deep packet inspection products out there. They're becoming more like standard. One of them is Snort. And when we implemented the deep packet inspection engine in our product, we had to avoid reinventing the wheel, and we had to also capitalize on the user and install base of Snort out there. So in a lot of ways, what you're going to see here, if you are used to Snort or you have used Snort before, it would look very familiar to you, and that was intentional. So in our deep packet inspection, we actually have it built on Snort and has the following components. The first component is the packet decoder, which basically, if you're familiar with the Snort world, we take the packets and decode them depending on the interface, and we prepare them for processing. Once the packets are available, basically what happens from there, it will prepare the data for detection engines. It will detect anomalies, so that's how we block, certain threats that are coming through the packets. And would also accommodate for defragmentation, because in a network the packets do not necessarily have to flow in nicely. They can be out of order. They can be defragmented, and we can also decode HTTP URIs and reassemble streams there. Once the packets and the whole stream is available, we have the detection engine, and we have two plugin interfaces. Again, that's very familiar to what we have in Snort. There is the shared object rules library where you can go in and put rules. And then also there is the rules which are applied to packets directly. In our case, out of the box, you'll find built into our deep packet inspection engine is support for what we call as asymmetric web filtering, so that we can scan, for example, the headers without having to look at the payloads. And that, by the way, gets deployed in very large operator networks where compliance is required. I'm going to take you through, again, the components here and take you through the different plugins and how we can extend the deep packet inspection engine. The first one is the preprocessor. Again, we spoke about that, where packets are examined and manipulated before being handled to the detection engine. But once they are assembled and ready to be detected, then we have what we call as detection. In the detection part of the engine, we can perform a simple test to test a single aspect. We can then actually have the plugins where we can extend the engine. And in our case, we have the shared objects rules library, where we can go and build new code. It's actually using C code library. Again, it uses the snort syntax. So if you're familiar with snort, you can do so right away. Or you can type in your typical rules, which would follow the snort syntax. And then basically, we have the output, which is reports results from other plugins. Now, the detection engine rules are, again, very similar to, in fact, they are, we out of the box from our engine, we support the snort syntax. So from there, this is an example of a rule that would detect the open heart SSL heartbleed vulnerability that was very common on the internet a few weeks ago. We were able to do that very quickly. In fact, the whole industry were able to do that very quickly. So if you had a WedgeOS installation, you'd have benefited from what the industry was doing there right away. Now, out of the box, our WedgeOS engine comes in with a lot of rules. One of them is for application control, which allows you to control the following applications: chat, games, P2P, and Tor. And we also have server security, because in a lot of our installations were installed to protect server farms. So we'd have your typical DDoS exploits and SCADA protection and so on. And then also you'd have the DPI web filtering, which we spoke about, that would provide asymmetric web filtering functionality. I'm going to take you now through further through the programming interface of the Wedge DPI engine. It's a bit extensive, but again, it builds on what the whole industry recognizes from snort. It basically is based on the snort shared object rules, which are known as the .so rules. You can write the rules in shared object rule language, which is essentially C, and then precompile it. And the benefits of this is that you can now have much more set of conditions, but also if you are a provider of a certain intelligence and you don't want people to know what you've been doing, you can obfuscate the code to protect your intellectual property. Our WedgeOS deep packet inspection engine comes pre-built with a plugin that would allow for integration. Actually, it integrates with McAfee's trusted source, such that you can scan asymmetrically for web traffic. Now, all of that is good, but the most important thing to recognize is how can rules be updated. And the update mechanism we have is called WedgeIQ, which is a signature distribution cloud. And the way it works is as follows. We actually have a lot of partners in the industry that would actually provide their own security rules. You can license them on a per need basis or per installation basis. And these are providers of DPI security and application rules. We also develop our own internal security rules, and these are available if you're a subscriber or if you're one of the customers of our technology. But all of that is distributed through WedgeIQ. And here it is. WedgeIQ is, think of it as the database of all of these rules, and these rules can be through our own threat intelligence, or could be through security rule publishers, and it's available through WedgeIQ, and it immediately updates all of your instances out there. So literally, it is maintenance free. Your systems would be updated as long as you have subscribed there. Now, WedgeOS comes in with a very easy to manage dashboard. So in addition to your typical command line interface which is actually similar to Cisco iOS, You also get a dashboard that allows you to quickly monitor the instances, their health, the signatures, and so on, but also allows you to put policies as needed. Now, here in wrap up, I'm going to start talking to you about how we compare and how we're different. And in a nutshell, the industry before WedgeOS had only deep packet inspection. And deep packet inspection was good because it allowed you to inspect for threats that are going through the packets, but it lacked because a lot of the threats are now coming through content. They're coming through your PDF files, through Word, and so on. And you need to basically be able to scan them. So the industry had deep packet inspection before, which had the next generation, which was deployed for next generation firewalls and intrusion prevention, intrusion detection systems. With our technology, with our patented technology, we now have deep content inspection where we are able to scan in depth, as we described earlier here today. We're able to scan the content, the payload. We're able to go through it in depth and prevent malware before it goes out. And in fact, WedgeOS has both types of engines inside it. So next time you are trying to compare security solutions, if you're a CISO or a system administrator, security administrator, or whatever have you, and you're considering what to do, look at it this way. There are proxies out there, so a lot of solutions are proxy-based, and this would be secure web gateways, mail transfer agents, and so on. And these are usually a single protocol. They would force you to change your topology so that you can proxy things through them. In addition to that, you are also going to have some typically poor performance. Deep packet inspection, as we talked about it earlier on, is great when it comes to scanning for packet-based threats because it has packet scope. But the problem is, on a general, on its entirety, on the whole malware and threat landscape, you need both deep packet and deep content to be able to block content threats. In fact, a typical rule of thumb is packet threats are usually around 30% compared to content threats. So content threats are becoming more predominant. So deep packet inspection would only protect you against packet threats, not the others. Now we have basically in WedgeOS, we have both the content inspection and the packet inspection. Think of it as flow inspection and content inspection. We scan all protocols. Our scope is both content and flow. We have line speed accuracy, line speed, we have high accuracy, and we have basically advanced threat intelligence. So the image I would like you to always remember is this. If you are going to use deep packet inspection alone, or you use proxy technologies alone, it's going to be that accuracy versus performance where you are going to sacrifice one of them. Either going to get high accuracy or slow performance, or vice versa. In our technology, you get both. Thank you for listening to this presentation, to this Chalk Talk. For further information, you can contact us in using one of the following.